Problem 36 says evaluate the integral of cos 3x sine 5x dx. So here I'm going to apply U-substitution, and what I've learned is that there are two methods to do this. So I will do this question using both methods so that I'm able to um, be efficient in both. So I will start with method one. So let me just say method one. In method one, it's where I will let u be equals to cos x. So when evaluating this function here, I can see that the two integrand, I've got cos 3x and I have sine 5x. So it's quite difficult to choose which one to make the u. So to make these things simpler, they've taught us, or I've learned, that I can use these two methods to apply them so that I can see if the answers I get are the same. So with method one, because I'm letting u be equals to cos x, it means that I will then have to find the derivative of u. So I will say du all over dx, which means that the derivative of u in terms of x, and this becomes equals to cos x. So now I will apply the rules for differentiation. So I know that when I'm differentiating cos or any cos, it becomes a negative sign. So this then becomes du all over dx equals to negative. So cos differentiates to sine x. So now what I want to do is I want to separate the two parts of the functions. I want to have my u on one side, and I want to have um, I want to have my du on one side, and I want to have my dx on one side. So then what I will do is I will cross multiply. So du will be equals to negative sine x dx. The reason why I do it like this is so that I don't miss any step. I know that, it takes longer to write the equation like this, but I've seen that if I follow this equation step by step, I'm able to see errors. I'm able to then identify how to do like this various problems. Remember, I'm learning with you. I recently took on Calculus A. I'm a pharmacist I'm pursuing a chemical engineering degree, so I feel like, if I understand this information, I'm able to apply it in various cases. Side note. So next, I will divide by negative 1, divide by negative 1. Oh, sorry about that. Okay, then I'll say divide by negative 1. So my du will be equals to, oh, now it's negative because I've divided by negative 1, will be equals to sine x dx. I've separated the du and the dx. It's now separated. So now what I want to do is I will rewrite my original equation. Now, this one, the one that I'm given here. So I will put my integration sign. Because I let my u cos x, I will then be looking into, changing this sin x to something I can work with. So what I've learned is something called Pythagorean identities. These Pythagorean identities relate the cos x and the sin x. So it says that cos squared x plus sine squared x is equals to 1. So then this means because I'm working with cos, I will then want to find the identity of sine squared x. So sine squared x will be equals to 1. Then I take the cos to the other side, it will be minus cos squared x. So this is what I will be working with. So when I rewrite my formula here, it will then become cos 3x. And then because it's sine 5x, I want to change this 5 to an odd number. So because I've already identified that I have this identity that I found here, I can change the sine x to become sine 4x multiplied by sine x. And then I'll put my dx expression back. So now I see that I've got my cos 3x, which I've let, which I will use as u, and then I can apply the trig identities which I have found in this case. But in order to do that, I need to make it a 2 here on top. So I can further simplify this to be cos 3x, open bracket, and make it a sine squared x squared sine x dx. Because I've simplified this as this, I know that to get to 4, I'll just say sine squared x, and this exponents will add, will give me this, and sine x for sine 4x plus, sine 4x multiplied by sine x will give me the original expression of sine 5x and the dx. So now that it's written like this, it is easier to then apply the trig identities. Okay, so in this equation, I have already identified that my sine x dx, which is this expression here, sine x dx, is the same as negative du. So if I remove sine x dx, I can substitute it as negative du. So now this goes on to be, I want to change every expression here, express it in terms of u. So this will become u exponent 3, open bracket. Applying these trig identities that I've applied here, that I've found here, I will say 1 minus, this is cos squared x. I've already said that my cos is my u expression. So this will be u, and then I'll put back my square sign, close bracket, say squared. So my sine x dx will now become my negative du. So this is minus du. What I have done here is that I have now changed everything from x to my u expression. So from here, I can further simplify this, not simplify, but expand this to be u exponent 3, and then in the brackets, I know that I can expand this to be u squared, close bracket, 1 minus u squared. Then I put back my negative du. The reason why I do it like this is so that I don't miss any step. In case I make any mistake, I'm able to see where the mistake was. So this further simplifies to be, so I put back the integration sign, u exponent 3, open bracket. So it's 1 times 1, this will be 1. Negative u squared multiplied by 1, this will be negative u squared. Negative u squared multiplied by negative u squared. So I know that negative multiplied by negative, this will become a positive. Did I miss something? No. Did I miss something? I think I did. So 1, 1, 1, and this. Okay. Yes, I did miss something. Let's see. So the first part, 1, let me do this so that I can follow. 1 times 1, negative u squared times 1. So it's 1. Negative u squared times 1 is this one. So the second part. So it's negative u squared times 1, which is negative u squared. Okay. So negative multiplied by negative is a positive. Then u squared multiplied by u squared. When the bases are the same, I add the exponents. So this will be u exponent 4, close bracket. I put back my negative du sign. So this further simplifies, put back my integration sign. So this is u exponent 3, open bracket, my 1. So the similar terms, negative u squared minus u squared. So this will be this will be 2u squared. Sorry about that. 2u squared plus u exponent 4, close bracket, negative du. I go on. This can further be simplified to be, so u cubed times 1, this will be u exponent 3. U exponent 3 multiplied by negative 2u squared, this will be negative, and then I put back the coefficient. U exponent 3, this multiplied by this exponents will add. So this will be 2u exponent 5. And then plus sign, u times u, the base are the same. So it's then I add the exponent 3 plus 4 is then 7, close bracket, negative du. So from here, I can take this -1 because there's a 1 here and take it out of the integration sign. I could have done this before, but I like to do one thing at a time so that I'm able to, not make mistakes and see where the problem was, if there is a problem. So this becomes negative, then put back the integration sign. This will be u exponent 3 minus 2u exponent 5 plus u exponent 7, close bracket, then du. So now everything is expressed in terms of u. From here, I can apply the power rule of integration, which says that x n plus 1 all over n plus 1. So if I have an exponent 2, I just plus, then I divide by the value that I get here. So this becomes negative. Because now I am integrating, I will then, when I integrate using the power rule, or when I integrate, then I know that the integration sign will fall away and the du will fall away. So let me start by integrating with this. So what this becomes is u, then 3 plus 1 is 4, divided by that same value, which is 4, minus, rewrite the coefficient, open the bracket, then it's u exponent 5. So put the base, 5 plus 1 is 6, all over 6, close bracket, plus u, 7 plus 1 is 8, all over 8, close bracket, du. This simplifies to negative integration sign. So open bracket, it's u exponent 4 all over 4 minus. So 2 divided by 6. So 2 divided by 2 is 1. So this is 1 all over 6 divided by 2, I know is 3. So this becomes u exponent 6 plus u exponent 8 all over 8, close bracket, du. Because I've already integrated, I know that the sign is going to fall away. So this and this will fall away. So what I then have now is equals to negative, and then a bracket, u exponent 4 u exponent 4 all over 4 minus 1 all over 3 u exponent 6 plus 8, not 8, plus u exponent 8 all over 8, close bracket. So it means then I need to fall. So after I've integrated, I remember that I need to add my c, which is the constant of integration. So after this, I will then fall with a negative sign. So this will be negative u exponent 4 all over 4 minus 1 all over 3 u exponent 6 plus u exponent 8 all over 8 plus the constant of integration. So now I can see that since I've already determined what my u is, I can just substitute my u back. So this becomes negative cos 4x all over 4 minus cos 6x all over 3 plus cos 8x all over 8 plus c. So this becomes my answer here. So as you can see here, I take a long route to explain how to do this. This is because I just want to make sure that I don't make any mistake. The first thing I do is I find my u expression, find the derivative of s. That after that, I express it. I express everything in terms of u and x on one side, and then I look at the odd numbers in my original equation. Because I let my u be equals to cos x, that means I will just be finding the other side. So I work on this and changed it to make it even. Then I take out the sine x because I've already found what sine x dx is. Then I went on to change everything to my u expression. After changing my u expression, I go on to evaluate using the power rule of integrals, which is this one. After using the power rule, then I know that the integration sign and the du falls away. I put my constant of integration with this one. Then when I have my u equation, I can now put back my u into the original equation and find my final answer. So this is method one, essentially. I know it took a bit of time, but the reason for this is to also just make sure that I follow appropriately and I know how to solve the problem step by step.